All right, so looking at the application problems for 4.4, right here we have this formula that's given to us. So we have A is equal to 25.1 times E raised to the power of 0.0187 times T models the population Texas A in millions, T in years after 2010. So the first question says, what's the population of Texas in 2010? Well, that would correlate with T being equal to 0. Okay, so T is years after 2010. So if it's 2010, T is going to be 0. So we'll have A equals 25.1 times E raised to the power 0.187 times 0. So then we're going to get e to the power of 0, and we should know this. Any base raised to 0, as long as the base is not 0, which e is not 0, will be 1. So let me write that rule down real quick. So if you have a base raised to the power of 0, it's going to equal 1 as long as the base itself is not 0. And that I'm never going to give you a scenario where the base is 0, so you're not going to have to worry about that. So this will turn into a 1. So we had 25.1 million people in Texas in 2010. Okay, the second question is going to be the more challenging question. Um, so here it says, when will the population of Texas reach 28 million? So this time A is going to equal 28, and then we have to solve from there. So let's see, we're going to have 28 equals 25.1 e to our power right here. Okay, so this time we're trying to solve for t. And so what we want to do first is isolate the base that has the exponent. So that 25.1 is not part of my base. So I'm going to divide both sides by 25.1. 25.1. And I would just leave it as a fraction here. If you wanted to put it in the calculator, that's fine, but you'd probably end up having to round quite a bit. So I would just leave it like that. And then we have, I'm going to give myself a little bit of space here, and you'll see why in a second. So I'm going to have e to the power of 0.0187 t. Okay, so now I'm going to use one of my properties from earlier in the section. And what I can do here is I can use the one-to-one property, which is that I'm going to take the natural log of both sides. Okay, so I'm going to take the natural log of the left side, and I'm going to take the natural log of the right side. Now, what that does for me here is that here's another property that we should know. If you have the natural, oops, let me write that a little bit better. If you have the natural log of a base raised to a power of x, I just call it x, it will equal whatever that power is right there. Okay? So what's going to happen is the right side's just going to simplify into, and I'm going to write this over here where I have more room. The right side, well, let's see, so I'm going to have natural log of 28.251, and then the right side's just going to simplify into that exponent, so 0.0187t. Okay? And then the last step we have to do here is divide both sides by 0.0187. 0.0187. Okay? And at this point, the calculator is going to take over. Okay? Here we go. So I've got to take the natural log of 28 divided by 25.1, close it. Make sure we got to close that. And then we're going to divide that by 0.0187. And let's see what we get. So we get t equals 5 point, around that to 5.85. So let's see. T equals 5.85. Okay, so just be careful. That is not actually our answer right there because they're asking what year this will happen. So it would be 5.85 years after 2010. So they're going to round that up to 2016. So that's the actual answer. So you're going to want to add that on to when the data started. Okay, and you're always going to want to round up on these. Okay, I think they should all, whatever you get, is probably going to be close to rounding up to the next digit, anyways. Okay, so I got a couple more, going to be fairly similar to what we saw there, at least the process. Okay, so right here it says if 4,000 is invested at 7% compounded monthly, how long will it take to grow to 6,000, round two decimal places? So first I'm going to write down the formula so we can kind of look at this. So it's going to be 1 plus r over n raised to n times t. Okay, so what do we know? So our investment is 4,000, so that's going to be our p-value. We are expecting a 7% return, so we got to put 0.07, and we're going to compound monthly, so n is going to equal 12, and we want to figure out, we want it to grow, we want it to accumulate to 6,000. And then what we don't know is how long is that going to take. That's what we're trying to solve here. Okay, so this problem actually, once we get going, this can be very similar to the one we just completed. So let's see, we got to plug in our values. So let's see, 6,000 for A, 4,000 for P, 1 plus 0.07 over 12 raised to the uh, power of 12 times t. Okay, so then what we'll do here is I want to isolate my base again. Okay, so I'm going to divide both sides by 4,000. So that cancels out here. And let's see, those zeros cancel out. And then let's see, that'll turn into 3 halves equals 1 plus 0.07 over 12 raised to the power of 12t. Okay, so there's a couple different ways we can go about this. Um, I could take the log base of both sides of whatever this number is right there, but I don't think that's going to come back very nice. So let's see, 1 plus 0.07 divided by 12. Yeah, I don't think I'm going to want to deal with that. So what I'm going to do here is kind of like the previous problem. I'm going to take the natural log of both sides. Now, in this case, that's not going to cause this to simplify into the exponent. That's not what's going to happen here. What we'll do here, because my base is base e, and that's not the same as this value right here. But what this will allow me to do on the right side is using my power property with logarithms. What I can do is I can move the 12t out into the front, and then I have natural log of 1 plus 0.07 over 12. So what I did was I moved the power out to the front. And then from here, I should be able to solve for t. What I'm going to do is I'll divide by the 12, right? The 12 right here. And I'm also going to divide by the natural log of 1 plus 0.07 divided by 12. So I have to divide both sides by this. Now this might be a little tricky when we put it into the calculator, so we're going to want to be really careful on how we do that. Okay, so let's see. So the 12 cancels out, the natural logs cancel out, so where now I've isolated t. So t is equal to this right here, but I got to figure out how to put this in the calculator, okay? Because if you don't put it in just right, it's going to come back incorrect. Okay. So what I'm going to do here is I'm going to put in natural log of 3 halves. Okay. Now, when I divide it, what I want to do is open a parentheses and then put the 12, and then you can put times if you want to, but you don't have to. Just type natural log of 1 plus 0.07 divided by 12. And then I need to close. Okay. So what I had to do here is I had to open up parentheses for my denominator and then close it at the end. I had two at the end because I opened a second set for my natural log. Now, the reason I have to do that is if I don't put a parentheses right here, right when I start my division, it will divide by 12, but then it will multiply by what comes next. But I want to divide by the whole thing, and that's why I have to put it in parentheses, okay? So if you're using a different calculator, I would probably figure out what this is on bottom first and just round, 4 or 5 decimal places and then divide it by the numerator just to be safe. So depending on what calculator you're using, just you'll want to be careful. And so let's see what we get. So that will round to 5.81. So it's going to take 5.81 years for that investment to grow from 4,000 to 6,000 under these given conditions. Okay. So hardest part might be, making sure you put it in the calculator right. So make sure you get a reasonable answer. If your answer comes back, you know, 54, obviously something's wrong. It's not going to take 54 years for the investment to grow a couple $1,000s. So, anyways, be careful to check for reasonableness. Okay, here's another one. This one, very similar. It actually might even be a little bit easier for us. It says if 3,000 is invested at 5.5% compounded continuously, that's what's going to make our life a little bit easier on this problem. How long will it take it to grow to 8,000 round 2 decimal places? So this time we're using the formula PERT, P times E raised to R times T. And so this one actually will be a little bit easier to work with. So our initial investment is going to be 3,000. Our rate of return is 5%, so you got to move that 2 decimal places. And then how long will it take to grow to 8,000? So once again, we're solving for time. So we'll go ahead and plug these in. So I want it to grow to 8,000. Let's start with 3,000 and then e raised to 0.055 times t. And then from here, we'll divide by 3,000. That cancels. This will reduce down to 8 over 3 equals 0.055t. And then what we'll do is we'll take the natural log of both sides. Oh, sorry. Forgot the e part right there. Yeah. So let's see. E raised to 0.055t. There we go. All right. So there we go. We'll take natural log of both sides. So this time my base does match the base of my exponent. So the right side will just cancel or reduce down to 0.055t. I was getting ahead of myself. And then what we'll do here is divide by 0.055, and we should have our answer. Now this one will be a little bit easier to put in the calculator because we're only dividing by a single value, not the product of two values. So this one should be a little bit easier. So, oops, not log. Let's see. Natural log of 8/3 and then divided by, you don't have to worry about parentheses on this one, 0.055. And let's see, 17.83 years. So time would be 17.83 years. Let me pull that back up so you can see that. And so once again, that seems pretty reasonable because your investment's almost tripling. And typically, yeah, I mean, a 5.5% return. That's a good return. So that seems pretty accurate to me. Okay, I've got one left. Okay, last one. A promissory note will pay you $15,000 at the maturity 7 years from now. If you pay 10,000 for the note, what that should say rate, not rat. What rate compounded continuously would you earn? Um, round three decimal places as needed. So once again, we're going to be using PERT. Okay. So let's see. The promissory note will pay. That's going to be the accumulated value. It's going to pay 15,000. It's going to mature after 7 years. So this time they're telling us T. They are going to tell us how long it's invested. They say that we paid 10,000 for the note. So we're going to pay 10,000 for the note. And so we want to know what the rate is. Okay. All right. So here we go. Let's plug in what we know. So we know the A value. We know the P value. We don't know R. We know T is 7. So I'm going to write it as 7 times R. I'm just going to kind of switch the order of that. Just makes it look a little bit nicer. So we'll start by dividing by 10,000. So that will cancel out here. And then let's see. This should reduce down to, I believe, what is that? 3/2. Okay. And then let's see, we'll have E raised to 7 times R. And just like the previous couple of problems, we'll take the natural log of both sides. So we'll get the natural log of 3/2 is equal to, and then that right there will reduce down to the exponent, 7R. And then we are going to divide by 7 on both sides, and this will give us our rate. Clear that out. So let's see. Natural log of 3 divided by 2. And then we're going to divide that by 7. And so we get, let's see, it said to go 3 decimal places. So 0.0579. I'm going to go a couple more decimal places, and I'll tell you why in a second. So let's see. Okay. Now I want a couple extra decimal places, and the reason why is you'll have to check when you're doing your homework because I can't remember. It will tell you if it wants it as a decimal like this. If it does, then your answer would be 0.058 if it wants it as a decimal. But if it wants it as a percentage, you'll have to move the decimal place back, and it would be 5.79. And I think did I round that 2 properly? Let me double check. Yeah, that 2 was rounded properly. Okay, 2%. And I think that this is actually how they're going to want the answer right here as a percent. So this will probably be the right answer right here. But double check. Pretty sure that they'll ask you for it as a percentage. And so just make sure you round those 3 decimal places. And so you just have to move that over back to like that. Okay, as always, if you have any questions, don't hesitate to send me an email.